Hi everyone. So this is going to be our last video in our exponents unit. We'll wrap up the exponents unit with our part 2 of our look at the one-to-one property of exponents. And I gave you a little bit of a sneak preview in part 1, and we're going to expand on that now. So let's take a look at a problem. If we have 2 to the 4x plus 5 equals 16, and we're solving for x using the one-to-one property of exponents. To remind ourselves what the one-to-one property was. The one-to-one property says that if we have two expressions, one on each side of the equation, and they are to the same base, we can set the exponents equal to each other. Well, in this case, they're not, and that's what we need to deal with in this video. What happens when your bases are not the same? Well, at least for these problems that we're going to be discussing, you have to make the bases the same in order to use that one-to-one property. So we want to know, can we write 16 as a base 2 expression? And the answer is sure we can. 16 is 2 to the 4th power. 2 to the 4th power. So now that we have a single expression on each side of the equation and the two bases are the same, that means we can take the exponents and set them equal to each other. 4x plus 5 equals 4. Subtract 5 from each side, you get 4x equals negative 1. Divide by 4, you get negative 1/4 as your answer. Sometimes it helps, just a little idea for you, to make a chart. I know the students who are on my class do this. Make a chart of the powers of the numbers, say from 2 to 9, so that you have this chart handy when you do these problems, so you can quickly look and see what the different powers are. Okay? And you would notice, for example, in this problem that 16 is found in the 2 line. So 16 can be written as a base 2. It can be written as a base 4 also, but we've already got a base of 2 here. Okay, let's take a look at a few more problems. How about 9 to the 3x equals 27 to the x minus 3. Now again, we want to know, can we write these two numbers to the same base? Well, 27 can't be written as a power of 9. There is no power of 9, no integer power of 9 that's going to give me 27. So if you have this chart, and this is why this chart's handy, find a row that has both 9 and 27 in it. And when you find that row, you'll discover that they're both powers of 3. 9 is 3 squared, 27 is 3 to the 3rd. So let's write that. 9 is 3 squared to the 3x equals 3 to the 3rd to the x minus 3. So all I've done is rewrite 9 as 3 squared and 27 as 3 to the 3rd. That way they'll both be to the same base, which means we can use our one-to-one property. Now we need to remember our power of a power property of exponents. That power of power property said that when I raise a power to a power, do you remember what you do? Multiply. 2 times 3 is 6. So we're going to use that same property here. So we've got 3 to the 2 times 3x is 6x equals, and careful now, 3 to the 3 times x minus 3. You need to be very careful here because you want to multiply 3 times this entire expression, which means you're going to end up distributing. So to write it this way is probably your safest bet. So let's finish it. 3 to the 6x equals 3 to the distribute. 3 times 3, 3x. 3 times negative 3 is minus 9. So I get 6x equals 3x minus 9. Okay? Subtract our 3x. We get 3x equals negative 9. Divide by 3, x equals negative 3. There's our answer. X equals negative 3. Okay? Let's do another one. How about 343 x plus to the x plus 5 power equals, oh, let's see. Let's make it a little trickier. 1/49 to the x minus 2. If you've made your chart, this would be easier, but even if you haven't, you might know that 49 is 7 times 7, 7 squared. So is 343 a power of 7? Sure is. If you take that 49 and times 7 again, you get 343. So 343 is 7 to the third power, 7 times 7 times 7, to the x plus 5, equals, now be careful, this is not 7 squared, this is 1 over 7 squared. And if you need a refresher on negative exponents, go back and watch that video. This is 7 to the negative 2. Reciprocals of positive powers are negative powers. So this is 7 to the negative 2 to the x minus 2. Power of a power property, multiply 3 times, make sure you put it in parentheses and distribute, equals 7 to the negative 2 times x minus 2. Okay? So when we distribute, we get 7 to the 3x plus 15 equals 7 to the negative 2 times x is negative 2x. Negative 2 times negative 2 is plus 4. Yay! All set. One expression on each side. Same base, 7. That means we can take these two exponents and set them equal to each other. 3x plus 15 equals negative 2x plus 4. Oh, what are we going to do here? How about subtract 4 from each side? So we get 3x plus 11 equals negative 2x. Subtract 3x from both sides. We get 11 equals negative 5x. So x equals negative 11 fifths. Divide by negative 5 on both sides. All right? Now, we did have one other problem that we talked about on the last video, our one-to-one property of exponents part 1, and that is what if there's more than one term on one side of the expression. So let's take a look at this one. 16 to the x times 1/4 to the x plus 3 equals 64 to the x. Our first question should be, is there a common base that we can use to express 16, 4, and 64? Well, there's actually two options here. We could write 16 as 2 to the 4th, 1/4 could be 2 to the negative 2, and 64 could be 2 to the 6th. Or they're all powers of 4 as well. 16 is 4 to the 2nd. 1/4, 1 over 4 to the 1st, is 4 to the negative 1. And 64 is 4 to the 3rd. Does it matter which one you use? Nope. I tend to use the larger base because it gives me smaller exponents to deal with. So I'm going to use 4. So I have 4 squared to the x power times 1/4 is 4 to the negative 1 because it's a reciprocal to the x plus 3 equals 4/3 to the x. Okay? Our power of a power rule says we multiply, so I got 4 to the 2x times, make sure you distribute, 4 to the negative 1 times x is negative x, negative 1 times 3 is negative 3. 4 to the 3 times x is 3x. And remember what we did on the last video, 1-to-1 part 1. We have to combine these. And how do we combine them? We use our product rule, which says that we add exponents. So that's 2x plus negative x minus 3 equals 4 to the 3x. Almost there. Almost. 2x minus x is x minus 3 equals 4 to the 3x. Right? Okay? Now we can use our one-to-one property. X minus 3 equals 3x. Subtract x from both sides. We get 2x, so x equals negative 3/2. Oh, let's do one more where we use the quotient rule. 27 to the, let's say, x plus 2 over, oh, how about 3 to the 2x minus 4 equals 1/9. 3, 9 is 3 squared, 27 is 3 to the 3rd. Looks like base 3, doesn't it? So let's write them at base 3. This is 3 to the, whoops, 27 is 3 to the 3rd power. raised to the x plus 2 over, this is already base 3, so we don't have to mess with it. We'll leave it alone. And 1/9 is 1 over 3 squared, so that's 3 to the negative 2. Okay? Do our power to a power in the numerator here. That's 3x plus 6, right? Because we're going to distribute. Don't forget to distribute. Over 3 to the 2x minus 4 equals 3 to the negative 2. Quotient rule. Talked about this on the last video as well. What do? We subtract 3 to the 3x plus 6 minus, and make sure you're subtracting the whole thing, not just the first term. Move up here. There we go. So I get 3 to the 3x plus 6 minus 2x, distributing that negative, plus 4. We have minus 4, don't we? Okay? So 3x minus 2x is x. 6 plus 4 is 10. Wow, that came down to a pretty easy problem, doesn't it? There we go. One-to-one property. One term on each side. Same base. X plus 10 equals negative 2. X equals negative 12 when I subtract 10 from both sides. And there we end our trip through exponents. Hopefully you were okay with exponents. And our next unit will be moving on to radicals, which are related in a way to exponents. We talked about that actually a couple of videos back when we did fraction exponents. But hopefully you're doing okay with exponents. If you need to go back and look at any videos in this unit to double check, that's what they're there for. Give them a shot, and hopefully you'll be an exponent wizard. Okay, thanks.